Okay, welcome to verifying trig identities. What I've got is 6 examples using trig identities to verify different statements. But before I begin, you have to know trig identities in general. So what I've done is I've listed 3 different categories, starting with the reciprocal identities. And at any point of this video, please, as I'm scrolling down, you can pause it and write these down because these are going to be really good references for any of these trig identity problems. So the first one is reciprocal. So for example, I'm not going to read these all, but for the sine of x, the reciprocal is 1 over the cosecant of x. So make sure you write all 6 of these reciprocal identities down. And if you want to pause it, like I said, go ahead and pause it. The second set of identities is the Pythagorean. So in the green, most of us probably have been shown this, where sine squared of x plus cosine squared of x equals 1. In red, I just showed you how we can rearrange it, like sine squared of x equals 1 minus cosine squared of x, and same thing with cosine squared of x equals 1 minus sine squared of x. The second one was 1 plus tangent squared of x equals secant squared of x, so all I've done is solve for tangent squared of x and set it equal to secant squared of x minus 1. And then finally, the last of the Pythagorean is 1 plus cotangent squared of x equals cosecant squared of x, and all I've done is solve for tangent squared of x, which equals cosecant squared minus 1. So this would be very valuable on the Pythagorean if you had them like what I have in the 3 Pythagorean identities and how we can rearrange it in what I have in red. The last thing is the quotient identities. And all I'm saying is, okay, tangent is the same as sine of x over cosine of x, and the cotangent of x is the same as cosine of x over sine of x. Now what we're going to do is we're going to use these identities to solve and verify some problems. So let's look at the first one. Cosecant of x times cosine of x equals cotangent of x. So when we're seeing something like this, we need to verify that, and I'm going to underline this, we need to verify that the cosine of x, cosecant of x, equals a cotangent of x. That's what verifying means. So when I'm looking at this, I'm thinking of, okay, I've got this cosine of x. But now I need to know, okay, cosecant of x. What is cosecant of x? Well, if I go ahead and look at if I scroll up here, now I'm not going to do this every time, but if I scroll up here to the reciprocal, cosecant of x is the same as 1 over sine of x. So what I'm going to do is I'm going to say, okay, cosecant of x equals 1 over sine of x. And what I want to do is I want to take this reciprocal identity and I want to plug it in for the cosecant of x. So now what this turns into is 1 over sine of x. Now, when I multiply those out, that'd be cosine of x over sine of x, which over here in the box right here, I know that the cotangent of x equals cosine of x over sine of x. So that means that equals cotangent of x, which this is what I just verified. So that is a true statement. Now, if this does come out differently, maybe this in purple right here was the sine of x over cosine of x, then that would be the tangent of x. That means it would not verify, so that would be wrong. At any point in this video, you can always, like I said, pause it and look at you can scroll up and look at your notes for my different identities. And you can also pause at any point during the video and work on it and then unpause it and see how I'm working this out. Okay, this is a similar one. On number 2, I've got sine x times secant of x. Well, sine of x, I'm going to leave that alone right now. But now I need to know, okay, what is the secant of x? What is the secant of x? Well, if you look at the reciprocal, secant of x equals 1 over cosine of x. So in this case, I'm going to sub for my secant of x. I'm going to put 1 over cosine of x. And then when I multiply these out, I get sine of x equals cosine of x. Which my quotient identity tells me sine over cosine is tangent of x, which that is a true statement. So this is actually correct. Now the third one, this is where I think some of us will probably shut down, shake our heads, because we're looking at fractions. And I know that's a whole different ballgame when we're dealing with fractions. However, we treat this just like we did the other two. So on this one, what I'm looking at is I'm looking at that tangent. Okay? So I'm not going to do anything with the cosine. But what can I do with the tangent? Well, I know tangent of x equals sine of x over cosine of x. So that means what I can do is I could go ahead and substitute my sine of x, cosine of x, for my tangent of x right there. So I'm going to say times sine of x, cosine of x. Now, if you want to, you can always put a 1 up under the cosine of x just to make it on the same lines and stuff. Make it a fraction. So now what I'm doing is I'm looking at, okay, this cosine can cancel each other out. So what is left is 1 over sine of x. Now notice right here, this is the same as what we're trying to verify. That is a correct statement. Now I can say, okay, what about 1 over cosine of x equals 1 over sine of x cotangent of x? So like I said before, at any point of this video, you can stop it at any time, go back and review it, work on it, and come back and see if you are correct. So let's take a look at this problem. Okay? So I'm looking at the right side. Now, 1 over, okay, sine of x I'm leaving the same. But now I'm looking at this cotangent of x. So cotangent of x equals cotangent of x equals cosine of x over sine of x. So all I'm going to do is I'm going to substitute the cotangent of x by the cosine of x, sine of x. I can put this over 1 if you want to. So now the sine of x cancel each other out, and what's left is 1 over cosine of x. And notice that this is the same, so that is the correct verification. Now we're going to get into the Pythagorean identities. Okay? So we need to verify that the secant squared of x minus cosecant squared of x equals tangent squared of x minus cotangent of x. Well, if you go back up into the beginning of the notes, if you've written them down, that, and I'm going to put this in a little box. Secant squared of x equals, if you look at our Pythagorean identities, 1 plus tangent squared of x. And then if you look at our cosecant of x, cosecant squared of x, that equals 1 plus cotangent squared of x. So those are two identities we need to use. So what I'm going to do is I'm going to substitute my first one in for secant squared of x. So it's going to be 1 plus tangent squared of x. And then what I'm going to do is I'm going to go ahead and I want to substitute my 1 plus cotangent squared of x in right here. Now here, be careful on this, because I've got 1 plus cotangent squared of x. What I'm going to do is I'm going to put that in parentheses, and I'm going to put my subtraction right here because I'm subtracting those. That will be a common mistake. So now what we want to do is we want to get rid of all of our parentheses and combine like terms if we have any. So what this comes along is I cannot do anything with 1 plus tangent squared of x. But now I can say this minus, you can treat that as a minus 1 and distribute it. So minus 1 times 1 is minus 1. Minus 1 times cotangent squared of x is minus cotangent squared of x. Notice right here, my 1 and my minus 1 cancels each other out. So what you're left with is it equals tangent squared of x minus cotangent squared of x, which I just verified. And finally, my last one, and like I said, you can pause this, work on it, and see if you've done this correctly. So in this one, I'm going to put my box here and put my identities. Now, on your identities, cosecant squared of x is the same as sine squared of x. Because all you're doing is it's the reciprocal. Okay, so At this point, what we need to do is we need to substitute this in. So this is going to be, when you substitute this in, it's going to be 1 over sine squared of x times cosine squared of x. You can put that over 1 if you choose. So that is cosine squared of x over sine squared of x. Now think about this. What is cosine over sine? That is cotangent squared of x. Now also our identity 2 is, if you, I'll scroll back up here. I know there's a lot of identities and going back and forth. But if you look at this, cotangent squared of x is the same as cosecant squared of x minus 1. So right here I know that right off the bat cotangent squared of x equals cosecant squared of x minus 1. That should have been an x there, I apologize. So this right here means I just verified it. So this concludes my lesson on verifying using trig identities, knowing your Pythagorean identities, your reciprocal identities, and also your quotient identities. Thank you for listening.